For millions of years, Earth had been a lizard's world. But then 66 million years ago, a rock from space ended all that. Or did it? Hi, it's me, and this is my channel. To answer that question, we have to travel back in time before the asteroid, before the meteor, before the impact, before the Cretaceous, before the Jurassic, before the Triassic, way back to the beginning. The story of the rise of the dinosaurs begins with a humble, unassuming ancestor, a small, slow-moving, insect-eating reptile not much different than today's lizards. No giant teeth or claws, no armor or frills, no long necks or tails. It was unremarkable in every way except one. Like all living reptiles, it was an amniote. It laid eggs with tough shells that didn't need to be laid in water. With this adaptation alone, they were free to live away from the water's edge and reign over the land. That first amniote would go on to kickstart three great groups of animals, the first being the dinosaurs. Dinosaurs appeared around 230 million years ago during the Triassic period. They lived alongside their cousins, the archosaurs, which split into two major groups, crocodiles, and the lineage leading to birds. The age of the dinosaurs began around 200 million years ago, when they first became the dominant terrestrial vertebrates. They ruled over the land for 180 million years until the asteroid impact. But even though they only held center stage for a blink of an eye in the history of life, their influence has endured. We owe our world to the dinosaurs. Some 145 million years before the asteroid impact, flowering plants first appeared. Until then, the world had been green, but not in the way we know. Mosses, ferns, conifers, and other non-flowering plants dominated the so-called Age of Green. For millions of years, there wasn't a single red or blue flower to be found. And yet flowers are responsible for the majority of colors we see in the plant kingdom today. If not for dinosaurs, we might still be living in a monochrome world. Okay, so we know that dinosaurs played a critical role in the diversification of plants, but what about the rest of the animal kingdom? Some scientists say that the evolution of dinosaurs spurred the diversification of mammals. See, during the Triassic, the ancestors of mammals were small proto-wombats, barely bigger than a mouse, and scurrying around on all fours. But towards the end of the Triassic, mammal-like reptiles known as cynodonts started hunting them. Mammals today can trace their ancestry back to the survivors of this episode of ecological upheaval. Maybe it was the development of new adaptations like fur and the ability to regulate body temperature internally that allowed mammals to thrive in a world dominated by dinosaurs. Or maybe it was simply the lack of competition. Whatever the case, mammals went from tiny proto-wombats to the diversity we see today in just a few million years after the extinction of the dinosaurs. Birds also owe their success to dinosaurs. Most paleontologists believe that birds are the direct descendants of theropods, a group of mostly carnivorous dinosaurs that includes Velociraptor and Tyrannosaurus rex. By the end of the Cretaceous, there were already a variety of bird species flying through the skies, many of which were already starting to resemble modern birds with feathers, wings, and hollow bones. This remarkable evolutionary leap is considered a rare example of major body plan innovation, along with the evolution of the mammal and the transition from water to land. So birds wouldn't be where they are today without the dinosaurs. But dinosaurs didn't just inspire the evolution of other life forms. Their own bodies were also constantly changing and adapting. You may be familiar with the image of the stiff-legged, slow-moving sauropods like Brachiosaurus. But this is actually a misconception based on outdated restorations. Recent studies show that sauropods had more flexible legs and were fast, agile creatures capable of running at speeds up to 30 miles per hour. In fact, some scientists think that the last common ancestor of all sauropods was a small, fast, dog-like dinosaur. Over millions of years, sauropods went through several dramatic size increases. Their growth rates were similar to those of crocodiles and alligators today, reaching sexual maturity at 10 to 15 years of age and maxing out at around 30 tons. Their body mass was so enormous that if they suddenly stopped growing at any point during the last sauropod growth spurt, they would have weighed the same as modern elephants. One reason why sauropods grew so large could be that they inhabited a world full of gentle giants. Herbivores like sauropods benefited from the lack of large predatory dinosaurs in the latest Cretaceous, allowing them to grow larger and larger. Had they lived in a world populated by giant meat-eaters, they might have evolved to be smaller. So the herbivorous lifestyle and the absence of large predators created a positive feedback loop, leading to gigantic proportions. It seems that the dinosaurs were well suited to the environment they inhabited, giving them the freedom to experiment with gigantism. And they weren't the only ones. The fossil record shows that the end of the Triassic saw an explosion of large animals known as the Late Triassic event. During this period, mammals grew to the size of bears, crocodiles reached lengths of 30 feet, and the first dinosaurs to exceed 1,000 pounds appeared. The Late Triassic was also marked by the appearance of the first marine mammal, the first bats, the first primates, and the first horned dinosaurs. So what caused this sudden radiation? A warming climate? Global temperatures increased by roughly 9 degrees Celsius between the Triassic and the Jurassic. With rising temperatures came more evaporation, which led to drier climates and the formation of vast desert ecosystems. To cope with these conditions, organisms evolved a variety of strategies like nocturnal behavior, burrowing, and the ability to control their body temperature internally. While the causes of this dramatic shift aren't fully understood, it does appear that global change was critical in shaping life on Earth. Sometimes driving the evolution of entirely new groups of animals, the planet's shape also had a profound impact on dinosaurs. Continental drift is the theory that the continents move over time. This idea was proposed by Alfred Wegener in 1912, who noticed that the coastlines of South America and Africa fit together like a jigsaw puzzle. But he was largely ignored until the 1960s when new evidence emerged, like matching fossils on different continents and variations of the same rocks. Today we know that the continents move on giant plates of rock and metal that float on top of a layer of molten rock. As these plates collide and drift apart, they reshape the planet's surface, forming mountains, valleys, oceans, and continents. This process, driven by heat from Earth's core, has been going on since the planet formed 4.5 billion years ago. It continues to influence the distribution of species today, affecting factors like climate, geography, geology, and the breakup of supercontinents. Pangaea, for instance, broke up around 200 million years ago, giving rise to the Atlantic Ocean and the distinct northern and southern landmasses we know today. This event is believed to have been a major driver of the diversification of life on Earth, including the evolution of the dinosaurs. It may sound counterintuitive, but sometimes the death of an ecosystem can lead to the birth of others. As the supercontinent broke apart, it formed large gaps in the global climate system, which dramatically changed the amount and distribution of precipitation. These changes may have led to the extinction of some 30% of all species, including many large amphibians, but also provided opportunities for new life to flourish. One example is the aforementioned radiation of mammals. The breakup of Pangaea also had a profound impact on the evolution of dinosaurs. Previously isolated populations of dinosaurs were now separated, allowing them to evolve independently, but it also brought different groups of dinosaurs into contact with one another. This mixing of populations may have played a role in the evolution of new species, and may explain the unusually high number of dinosaur species in the fossil record during the Jurassic period. So from their humble beginnings as unassuming lizards, dinosaurs evolved into an astonishing array of shapes and sizes, influencing the evolution of plants, other animals, and even the planet itself. And yet they only survived for a blink of an eye in the history of life. So what happened? Join me next time to find out how dinosaurs died and how we know so much about them. Thanks for watching.